All right, kids, really quick life lesson. In life, you're either the hammer or the nail. I want to show you what a hammer does to a nail, all right? Right down here on this board, you got two nails in here. I'm going to try and pull this top one first. Let's see if I can do it. We're going to pull it like this. All right. Boom, got it out. See that? I was able to pull the nail out using the end of the hammer very easily. Now, let's check out this one, this nail down here. Ah, not happening. I'm bending the nail. If you can see that, I just bent the nail a little bit. This hammer right here is a little bit too small for that nail. Let's try something a little bigger. This is a wrecking bar right here. It's a high carbon steel for extra strength. It says so on the packaging. Let's see if this does the trick. I mean, light as a feather. All right, go ahead and tell me just easy. What is the difference between these two objects? What's the main difference you see between these two objects? All right, let's try another example. I'm gonna try screwing these in using just a regular screwdriver. Here we go. Gets really hard right about there. Let's try this one. Look at the handle, much different. Let's try this. Oop, that's the wrong bit. Much easier. Goes in without a problem. I don't even have to use my whole hand. What's the difference between these two? All right, I got a lag bolt inside of this piece of wood. This is called a lag bolt. It's got a pointy end on the end of it. Let's see if I can't. Yeah, impossible to do it with my hand. I can't do it at all. Now check it out. This is called a ratchet. See, look, it's got the little hex head on it. Hex head. So I'm gonna start ratcheting this thing. Wrong way. There we go. Hear that? I spin it one way and it tightens it, and then as I spin it the other way, it loosens up so it doesn't move the bolt, so I can spin it nice and easy. And look, if I spin it on the edge, it takes almost no effort. But as I keep on going down, it gets harder and harder. So I have to start gripping it more and start putting more into it. Now, I pick up this behemoth, which is called a torque wrench. So I can set to how much I want this to actually wrench down. But for our purposes, you can see this takes almost no energy to do. So go ahead and tell me what's the difference between these two objects right here. All right, so by now I guess you noticed the difference, that the difference is just the length of the handle. Look at the difference between these two right here. Right, it's almost double the handle size right here. So let's watch something right now. Let's look at the radius of which this handle moves versus how far we're trying to actually move this bolt. All right, so if, I have to move it. I might have to do it like that, yeah. So watch this, right? I'm gonna, our wood piece is moving back there. This piece is moving.
Okay.
Yeah, you might have to hold that. Yeah. All right. There we go. That's better. So, look at that versus right there. And look, I'll even finish it out. So look at the radius between these two. The radius from the center of the bolt to here versus the radius of the center of the bolt to here, from the center of the bolt to there. That's a huge difference. Now let's look at our big bar. All right. Get that attached on there. Again, we're only moving the bolt this far, right? We're only moving it around the center, but we're applying a force that's all the way out here. All right, check it out, guys. We took the bolt out, but I wanted to show you something. So this is the radius that the bolt is moving right here, right? That right there, that little object. Now look at how much longer this little middle radius is for the medium-sized socket wrench, all right? And now look at how much longer this line is for the big torque wrench. However many times this radius line fits within these lines right here, that's your mechanical advantage, all right? And we can write it like this. The formula looks like this. All right, so let's measure this out. This little smallest one right here, the smallest radius is about 2 centimeters, okay? That's how much the bolt is actually turning. Now let's look right here. That's sitting right at 17 centimeters from the center of here to right here to this arc. So we can find our mechanical advantage like this. We'll say our mechanical advantage, our MA, is equal to our longest length, our 17 centimeters, divided by the radius we're actually doing it, which is 2 centimeters. And we'll get mechanical advantage of 8.5. Now let's look at the other one. Let's see how far that one measures out. Right at 34. So let's do this one more time. Our mechanical advantage of the torque wrench is 34 divided by 2, which gives us 17. That's how you'll find your mechanical advantage. It is the amount or the radius you're moving, whatever object you're trying to move, versus basically the length of your handle.